Welcome everybody. I would like to give a presentation about big data for smart farming. It's quite a generic topic. And in this presentation, I will not really show any concrete initiatives or results or projects, but it's mainly a kind of a wrapper for the whole day regarding big data and provide some insights that we had when working for agricultural monitoring, but mainly to come up with some discussions points, some food for thought that maybe we can discuss a bit further later on during the roundtable. Because if you looked at the presentations today, I think it's clear that everybody's working in agricultural monitoring, working with different kinds of sensors, producing all kinds of data, all with the aim for providing an added value in the agricultural value chain. It can be for the farmers directly, but it can also be for different actors in the value chain. And here you see a clear example of different technologies that are currently envisaged, also discussed today with different presenters. It can go from in situ sensing, close sensing on tractors and robots. It can be the more remote sensing with drones, planes, or satellites. You have weather stations. You have ancillary data coming from the farmers themselves as well. So you have all these kinds of data that are combined into a certain service or product, which is then used by a number of people. It can be the farmer itself, like I said, but it can also be governments or advisors or agricultural consultants. So what I would like to talk is about this triangle of the data. Like there is a lot of data. We produce a lot of data, but I think by now everybody knows that, well, the data itself is not going to do the work. There are a certain number of conversion steps needed to go from those data collections to information where you convert them into certain products that tell you something about the system you are monitoring. Like, for example, we had this morning an example on monitoring of the tomatoes. So you take images, so you generate data, but you convert them afterwards to, for example, the color, so you know the ripening stage, or you convert them to sugar content, or like Vasilis showed, you convert it to phenological stage of your crop development, and it's only then that information will be used further into actions, and you learn more about the system than you can do without this type of information. Very generally, it's not entirely correct. It's a bit binary thinking, but just to ease the discussions, you see that the bottom half, the big data information, is typically what the people that present today are doing. So we collect data, we convert them into certain information products, and normally then they will be used by advisors or farmers in the next stages. Like I said, it's rough. Some people do the whole triangle. Some people only do one of the sections, but generally speaking, you can divide it into two parts. And so I will focus on the big data, and why the big data? Because I think we have to make a bit of distinction here between the data that we produce and all the data that's being, or the information that's being transferred then to the farmer, for example, that he is using. And there's a whole layer of data that's well, it's visible and everybody knows about it. It's not really always visible to the farmer. He doesn't really know about that underlying layer of information that's needed to make and run the operations that we do. If you look also at the technology today, for a long time, the data was a missing link. It was an issue. We couldn't collect enough data to do precision farming. The technology was not there. But I think today we've come to a stage that technology is ready to do what it promises to do, at least already to a large extent. Also, there have been enormous progress in, for example, all the computing power, the cloud infrastructure, how to manage the data. And on the third side, there's also on not only the processing power, but also the machine learning, the information translation or the data translation into information has also evolved and is still evolving very rapidly. But it means that you kind of have this conversion of technology. On the one hand side, we have the data generation with the sensors. There is the computing infrastructure that's also evolving. And you have the machine learning, so the data processing itself. And it's all coming together, but and so it's enabling a lot of things. Because of it, we can do a lot of great things. There's new information we can obtain and can provide to a whole range of users. But what I see now is that the bottleneck is slowly becoming into a different kind of data, and it's the reference data, the data that we need to train our models to go from the big data layer to the information layer. And that's a bit what I would like to talk to you about today. It's something that's playing not only on the precision agriculture or the smart farming layer, but it's actually playing on every layer of the agricultural monitoring. So you can go to the very detailed monitoring in greenhouses and experimental fields, more the phenotyping component. You can have the precision farming component where you try to understand what's happening at the field level, but also more at the regional level or the landscape level that you see what's happening, for example, with the insurances and other applications as well. It's happening on the different layers, but the way it's manifesting the issue of data availability is different for the three layers. And that's a bit what I would like to talk about. If you see, for example, if we start at the most detailed layer, the phenotyping. So for example, seed breeders, they make new varieties. They would like to make more disease-resistant varieties, varieties that are that require less inputs, that are more efficient. There's a whole range of optimization going on in the breeding field. And they really drive on data. They generate a huge amount of data. They have these experimental plots in the field, hundreds and hundreds of very small plots, each planted with a different variety, and they need to monitor them very closely. So there's a lot of data generation, a lot of manual labor as well. So here you already see that they're converting to, for example, drones to replace part of the field work to make more robust measurement protocols to evaluate their different breeding lines. So it's something that, for example, we do through the Mapeo platform, but what I would like to show there, it's a very short distance between the data, the big data layer and the final end user. There's basically just one layer. They produce it often themselves. We convert them into information and they use it directly. So here's a small example, for example, in wheat breeding, where they want to optimize the number of ears, or that's what they're measuring at least. So it's a very time-consuming work, but you can do it easily with drones. So you have machine learning that automatically detects it, and you can count it. So for them, it's very clear and very direct what remote sensing can do and what you can do with these smart technologies. So they see the drone data. For example, as you can see, they can work with the data themselves. They can say they can delineate missing or errors in the model themselves, and they can improve it. So for them, sharing data is not an issue at all, because they see the added value for them. We have the images, and what comes out of them is of interest for them. It's a very short communication line, so they're really open to sharing data. They're really enthusiastic. It's very fun to work with these kind of people because it really moves fast and it's very concrete. So there it's easy to go with remote sensing and producing useful services for them. But if you go to the field level, for example, you go to farmers, and so that's where we come with the smart farming concept. The distance gets already a bit further. We have to make certain products, for example, yield prediction, that requires a lot of ground data. We need to know a lot of yield information, historical data on what's been happening in fields, which varieties were planted, planting dates, interventions in the field. So a lot of information is needed before you can start making useful EO products. There are some basic information layers that you can do, but you see that the farmers and advisors, for example, quickly ask for more concrete variables. For example, typically the NDVI is used, but more and more the farmers and advisors are asking for more concrete variables. For example, they would like to have biomass production instead of the NDVI, instead of having generic start of season, end of season, for example, regarding the crop development. They would like to know the planting dates and harvest dates and emergence dates. So it's very more concrete information, but there you need a lot of reference data. And then you can start seeing that sharing that data. And that's also what we do in eShape in our pilots. We see that obtaining the data that we need to make the services becomes more difficult. As a concrete example, for example, in Belgium, in the potato industry, so we advise or we monitor every potato field in Belgium. The first year we launched it, the farmers were very skeptical about the whole system and the need to use it, and especially sharing data, because we asked, for example, just a variety and their final yields per field, and that's something they wouldn't want to share because they didn't see what was in it for them. They just thought they had to provide information that could be used against them at some point. So they didn't want to share it at all. But now more and more they start to see the added value. For example, one of the services that's included right now is a benchmarking exercise where they can see the performance of their fields for a specific variety against similar fields in the neighborhood. So of the same variety, and then they can see, well, my field is doing better than just the fields that are close by with the same variety, so I'm doing well. Or if you're performing poorly, then he knows he has to do something else, or he can start thinking about what might be wrong. Maybe it wasn't the right variety for that field, and other questions. So now it's the uptake is really increasing now, and also the data sharing is increasing because they see if they provide their variety data in the platform. Initially, there is no direct use for them because providing that variety information is not doesn't have any added value for him, but it enables us to make that benchmarking exercise, and that benchmarking exercise is useful for him. So now he starts to see the added value, and they start sharing the data, but it takes time and it takes a lot of patience. And if you go even further, so that's for the farmer. If you go even further, for example, the insurance example we saw earlier from Nikos, and we also have within eShape other insurance pilots, for example, in Ethiopia. We at VITO have been doing some insurance work ourselves. It becomes even more difficult because the distance between the one who's providing the data and the added value for that data is becoming less clear and less obvious. So for insurance monitoring, historical information about, for example, just your productivity, your yields, it's very important to do your benchmarking exercise. But in the framework of an insurance application, the farmers are really not very eager to share it with you. So then you can see the distance becoming even further, even longer, and the sharing appetite is decreasing even further. Also with CAP, the Common Agricultural Policy, farmers are really skeptical about it. They're not really happy about it. So their sharing data in that respect is even more of an issue, even though it could still be very useful for them, but they don't really see it and hear the aspect of control. They think that the government wants to control them and check what they're doing. Becomes an even bigger issue. Also, again, within eShape, we've been working, for example, on the exact harvest date, because it was identified in the co-design approach as a essential agricultural variable, not only for CAP, but also from other applications. And so it's in essence, with the data that we produce nowadays with the satellites, Sentinel-1, 2, it's really easy to make it at the field level. From a technological point, that's really not an issue. But that's a clear example of the development that's currently being impeded by just a lack of reference data and people who have the data that don't want to share it because there's no direct gain for them in it. So yeah, just an example of what we did there within eShape. It's only shown for the months, but we have the exact day as well. It's just hard to show in a figure. So within eShape, but also another project that we work, there's a lot of work on the whole data component, because of course you have your GDPR compliance. In Europe, it's important that when you collect data, that you treat the data in compliance with GDPR. So also within eShape, there's a lot of attention on that aspect, and there is software available now that lets you check your applications if the way they handle the data is compliant with GDPR. Another one is just organizing your data, and because everybody produces data, there's a lot of, typically you share the data once through an FTP or via email or WeTransfer, but there's also a clear need for a more centralized approach on if the data is open and free for everyone to use, that it should be also stored in a central place. And there's a lot of initiatives ongoing right now, and you have these big data platforms from different organizations. And also here in eShape, we're working together with Wageningen. They're one of the partners as well, and they have AgroStack, which is really targeted towards agricultural data that's freely and openly available for everybody. It can contain information about just your crop types, or there can be productivity information, there can be phenology information, your development stages. It's a bit what you want to put in it. But within eShape, so it's one of the components that's really targeted towards data organization and making it freely available for everybody. And just to conclude, some food for thoughts, maybe later also, I think, to link it with the other presentations. It's really, if you would like to have precision farming and agricultural monitoring in general advance even faster than it is today, we really should work on the data sharing. So how can we stimulate it for the different entities? So it's not only the farmers, but also other organizations or commercial companies that have a lot of data. So how can they be stimulated into making it available? We should also look at why the farmers are reluctant to share. Sometimes it's fear that they shouldn't have. The reasons are not really there. Sometimes they are right not to share. I think maybe they shouldn't be so open sometimes, but there's a lot of misconceptions as well. So how can we work on that? And once we have all that free data, how can we actually organize it efficiently? It's not an easy task. It's not a one man's job, but it's something that the community should think about. And also, yeah, if you have all this data, how can you work with certain standards like data formats? Your metadata is extremely important as well at the different levels. So you can have European standards, but then you need to put it on a global level as well. So that's also something that we should look into. So that was it for my side.